All right. If you look at the annual GDP of what AI is expected to deliver by 2030, it's about 4 trillion US dollars. And that can be summarized in terms of what you would see in Europe and in France as an example. But what we're also seeing is that 98% of the enterprises have experimented with generative AI. Experiment being the key word, right? And the other key word here is generative AI, because we're going to be talking a lot about Gen AI and inferencing. And I know at the back of your mind, you're probably thinking, how does this relate to what I need to do in my organization for machine learning and deep learning and the different models that go with it? But what we're also seeing is that nearly all enterprises are stuck at the starting line with only 5% seeing return on investment. And for those of you that attended my opening session on Tuesday, you'd have seen that 85% of the organizations that are testing AI say that they would see the return on investment within the next 3 to 5 years. But what is the challenges that are preventing them from basically seeing this sooner? Number one, you would see is data integration. Now, organizations have data sitting in different places. The data is not clean. So if you're going to run AI on top of it, it's going to be a garbage in, garbage out situation, right? So, and this is where a lot of the challenges come in. The second thing that you'd see happening with the data is, where is the data sitting? In country, out of country? Do I need to do it on-prem? Do I need to run it in cloud? Skills become an important item. It's not just the IT team that needs to have AI skills. It's the line of business as well, because AI spans an entire organization, not just the infrastructure team. Most often as we speak to clients, we find that the IT team is ready, but the business is not ready. And then we have other customers where the business is ready, but the IT team is not ready. Or the organization is ready, but they don't know where to start. They do not have the infrastructure, which is where everybody thinks. They do not understand the stack that goes together, and it becomes a challenge. The good thing is we have a journey from IBM in total. When you look at the IBM AI strategy with Watson X and our cloud offering, and then from an infrastructure perspective, mainframe has its AI offering, Power has its AI offering, storage has its AI offering, giving you as a customer the flexibility if you're running any one of these IBM's hardware products that you can take care, embark on the AI strategy that we have. So when you're looking at deploying an AI, environment in your organization, it has to scale the entire organization, right? And what you would like to basically AI to help you in your organization is, how do you get competitive advantages, which is what customers are looking for. Now, I have a question for you. How many of you in your customer environment, not your personal life because you're probably using ChatGPT, etc., but in your environment at the office, doing anything with AI, testing, POC, demo, bought some infrastructure? How many of you are, on that journey? Few of you. Okay, good. Thank you. So what we're seeing in terms of how we've actually, got feedback from some clients, right? I mean, we're seeing clients that are saying that, they were running the AI inferencing workloads on Power, seeing up to 5x, improvement in terms of enterprise workflows. This statement here came from Jasmine, from MR Williams. This was done during our Power 11 launch activity. And she was, MR Williams was a early adopter of the Watson client code assistant, which the team spent some time speaking about yesterday. And then you're probably aware that we've now changed the roadmap for Code Assistant on Watson Code Assistant to Project Bob, right? But just, what she saw with, with Code Assistant running on Power 11 was they were able to get 18x more productivity in terms of just Code Assistant running on Power. And then we had, Shibuya based in in Europe was able to run, the Gen AI on Power up to 23% lower TCO versus x86. Now, when you look at the entire stack, this is what I was saying earlier on, we got customers that are faced here with the infrastructure because everything that they think of when they think of AI is GPUs. You don't necessarily need GPUs, and I touched a little bit of that on Monday, and I'll share a little bit more about that today. The second thing you need to look at is what are the foundation that I need to build on? Is it built on OpenShift? What is the ecosystem that I need to use to be able to build the next layer up from the infrastructure? And then when you look at the data fabric level, what are the, where is the data residing? Do I need to pull the data together? What are the tools I need to have? And what are the database applications we have? Now, if you've been following our roadmap, you'll see that we have Watson.X.data is currently in tech preview. And then on December 10th, it's being announced and will be available on Power. So customers have the opportunity that are embarking on an AI journey that they can start the journey on Power, and you can use Watson.X.data capabilities. The team yesterday spoke about assistants and agents and Project Bob. And then when you look at an ecosystem perspective, as IBM, we are doing a lot of testing. Mark will share later on the RAG demo and the use case. But in Montpellier, the team is also doing a great amount of testing for customers. With the new Power 11 server and the new Spyre adapter, we have about 7 clients around the globe that is doing testing for us. And, I'll share later on a little bit more on that. So you have to look at the entire stack from infrastructure all the way up to the ecosystem. Now, these ecosystem partners here, like Equitas, Rocket Graph, Funicle, Wallaroo, have come to IBM and said, our applications were running on x86, but we understand the technology that you have on Power, and we want to test our application on Power. I had the opportunity of meeting with all of them. I spent a lot of time with Equitas. Equitas does, they do a lot of work with the US Customs and Border Patrol with video analytics. They don't capture the video feed, but they analyze the video feed. And it's used in border control and border protection. But the same use case can be applied in retail as an example, right? If you want to look at how you place products on the shelf in a retail store, hot aisle, cold aisle, etc. And Rocket Graph actually did a very similar thing, and they came forward and tested the application, and the throughput was amazing on just Power 10, by the way, with the MMA architecture, and using vector databases and can help banking clients with fraud analysis, as an example. And then Funicle, as you know, is a core banking database provider. And what they did was they said, we got many clients running our core banking on Power, and we want to infuse AI on top of this to give customers the ability to run artificial intelligence and analyze the data that's being processed on Power. So when you look at how this is kind of played out today, right? I mean, you have your Power infrastructure sitting on-prem, and then you have some services that are probably sitting on some on-prem specialized AI infrastructure. You have your cloud services giving you some cloud capabilities. And then, you would probably go through the situation of, let me have a look and see what I can do from my data integration. There's obviously complexities that come with it from a network perspective because latency and resiliency become an issue. How do I build, deploy, and manage my AI solutions? How do I integrate this from an enterprise workload perspective? And then when you look at security, security becomes a big challenge when clients are considering especially AI, right? And you'd see the tug of war that exists in the organization between the data team, the security team, and the IT team. And then, that's about protecting the sensitive data. And then when you look at the skills perspective, it touches across the organization, right? IT operations, you need your data science people, DevOps, and your security teams working together. Now, what if we can bring all this out together in your Power server and give you the ability to take into consideration security, give you a database with what's in extra data that you can then run your inferencing on Power. And also, your Gen AI workloads together with some machine learning and deep learning as well. So we announced Spyre last year with a statement of direction. It's been in tech preview, and it becomes generally available in December 10th. Mark, my colleague, corrected me. And basically, it's about giving customers the ability of buying a server with off-chip acceleration, which is what you'd have with Spyre, that will give you one click in terms of getting it installed. Will give you the ability of selecting and getting it configured very easily, and then being able to give you, document embeddings with the knowledge base that we have. And when you look at some of the use cases, and this is about getting Spyre installed, right? About the one click. There's no sound to this, so if you just follow what's happening on the screen, you would basically select, your use case. And then basically select the adoption patterns, your pre-built services, and then click your install services, and you get it installed. So it's about one-click install. So that was the installation completed with one click, which basically takes into consideration all the things that the IT team needs to go through. And similarly, if you want to go and look at the other use cases, these are the ones that we have thus far in tech preview. It might change when we, go announce next month to enable customers to do an easy install of the Spyre adapter in the Power server. So what are some of the use cases that we're seeing that's coming out, right? You have your cross-industry use cases, you have your industry-specific use cases, your adoption patterns that we're seeing thus far that's being tested, and then your pre-built AI services. I do have a little bit more details on some of the use cases, so I'll switch to that. So digital assistants, you heard a little bit about Bob yesterday from the team, but what some of the teams are actually testing is, in Germany as an example, we got IT service tests being tested. We've got digital assistants being tested from a RAG perspective. We've got government clients testing private document assistant. We got a client in India doing an agriculture assistant. We got Banfast, a real estate agent, being able to do some testing as well. And then they're looking at, managing their knowledge. They're looking at, Q&A, translate and summarize. And then there you have some feedback from, Banfast, the real estate company, and then Edfast, the company in Germany, that's basically give us some feedback in saying that it's a truly plug-and-play AI solution, right? And then from Banfast, it's about data protection standards and compliance with EU national regulation. So from, we went through this one, sorry. When you look at order processing, and I have a chart that will take you a little bit in terms of order processing, Sky is based in Germany, what feedback they've given us, and the adoption process that they've went through, and what they were actually looking to do from, with another partner we're working with, was PII, checking. And the good thing about the PII client and document processing, the test is being done by Mark and the team in the labs in Montpellier. So in the case of Hans Kais, they had they want to improve their business processing rate. They run IBMI. And the second thing is they wanted to make sure they get their teams much more productive. Those are the two goals that they had in mind. And having run the test, they've seen a 5% increase in business process rate with AI integration, and they were able to achieve the time spent in processing of orders. So they're running IBMI, and they get the orders come via email, which meant that there was a lot of manual work being done before it goes into the ERP system and the processing system for a quote to go out, etc. And they were able to automate the entire thing with, Spyre and Power. So you have simplified AI onboarding, moving between cloud and on-prem, and I know that might be a bit of a challenge based in certain countries because of data sovereignty and security reasons. But in general, you can, from an explore phase to testing and getting to launch, right, with Power 11, with Spyre attached to that. So this also touches the order processing that we spoke about and the real estate. Data content, this is Crest, a business partner that's based in Kuala Lumpur. That's the test that Mark and the team is doing with them in Montpellier. They actually ran a few use cases. They bought a Power 10 server, and with that they did document processing. And now they're actually doing PII on top of the document that they're actually working on. This is a demo of actually what, with PII, with Crest. And in this case, they've actually taken a resume or a CV of an individual. And as you know, people capture a lot of their private information in a resume or CV. And this use case basically extracts that information so that, if the CV is being forwarded in different places in an organization, that you can then remove that information. So this is all the private information that it picked up. It notifies you, and then you can decide how you want to actually manage that, right? So Hemant Prasad, the CEO of Crest Info Solutions, which Mark and the team is spending a lot of time chatting to them. I had the opportunity of meeting with him, about a year ago in Kuala Lumpur, and he basically said, he's having great fun working with Power 10 and just the MMA integration into it. And now with Power 11 and Spyre, he's, leveraging the capabilities of Spyre for PII redaction with his document processing as they sell that as a solution to clients. So that was the use case. Data and content management was what we focused on with them. Recommender system is another one being validated in Spyre. It's more applicable to retailers. So you all shop online, I'm sure about that. When you buy a product online, let's say, for example, you buy a running shoe, and then suddenly you get a pop-up saying, people that have bought running shoe before bought this pair of socks that go with this pair of running shoe that go with this. Is actually what a large US retailer is doing, because they're finding that many of the online shopping carts have one product, and they had no option to add in a system to recommend. And I'm sure you have encountered it. For me, it's a little bit irritating when I get the recommendation come up because I know what I want. And in some cases, it works because you sometimes forget, right? But also, if you look at how recommendation works, is that if you buy a pair of running shoe, you might think you only want the running shoe, but there's a lot of things that go with that, right? You need specific running shorts, you need specific running vests, etc. So a long list of use cases that we're testing across industries and industry specific that's being tested, and we will continue testing as we work with clients. And once we launch this and go live next month, we'll be having a lot more customers that are buying, and we'll want to run different tests. And together with client engineering, our expert labs team, and our Power technical team, we'll be working with these clients, and we'll keep sharing that. So you've probably seen this chart before, but I want to touch on just a few items here. The Spyre adapter, this is what it's, this was designed by IBM, IBM Research came up with this many years ago. And then, they took it through different levels within IBM. And then when mainframe was launching the new mainframe, they screamed and they said, we're going to put Spyre in mainframe. Then when we launched Power 11, we made some noise and we said we want it as part of Power because our customers want that as well. So you're getting 300 plus tops on the actual adapter, one. It's a 75 watt PCI Gen 5 adapter and 128 gigs of LPDDR memory, which is sitting on here. Now, what you actually would see is this is a low voltage or power consumption card, which is a big thing when you consider the electricity consumption of AI adapters. If you've been following what's been happening on the press recently, and I'll share some of the stories that I've been in, some of the cases that I've been involved with. But before I get to that, I just want to share with you, you probably all use ChatGPT, right? Now, ChatGPT 4 uses 0.14 kilowatts of electricity, for 100 words that it generates, 0.14 kilowatt. Assuming that they have 400 million active users, which is what they have, and each one of those users prompt ChatGPT 5 times a day, you're going to be using 39.98 million kilowatts of electricity per day, which basically means that you can charge 8 million smartphones in that same time. Sorry, that was per day. Now, if you look at it per week, it's 280 million kilowatts. You look at it per month, it's almost 1.2 billion kilowatts of electricity per month, which is more than enough to power 332,000 electric cars. Now, if you go to a year perspective, it's 14.48 billion kilowatts per electricity. That's more electricity than 117 countries in the world I actually can use. That's what AI, ChatGPT, just using ChatGPT, one, because they use NVIDIA GPUs on the back end. That's the consumption of electricity. I heard the other day that there's regulation being put in EU. Some countries are saying that you need to make sure that you do not buy electricity, you need to get electricity efficient adapters if you want to implement artificial intelligence. And why is this important? Now, I had a partner speak to me about a month and a half ago, and he basically came to me and said, Ronnie, I need to understand your AI strategy from Power, and I have a critical situation. I said, well, what is the problem? He said, I have an order for $10 million, and I can buy IBM Power, but will AI run on it? I said, well, it depends. But the answer up front, before I can give you more information, is no. He's like, why are you saying no? I said, well, let me explain to you what I mean by that. You need to understand what the workload is. You need to understand the use case. You need to understand all the items that I spoke about early on in terms of how we actually build a stack and the software capabilities, etc., before you can actually say that I want to buy AI infrastructure. And then he gave me his problem. He said, I can't find these servers from Lenovo, HP, Dell, Supermicro, you name it, because there's no GPUs available, right? And this is why I would like to buy the IBM solution. And the second time he asked me, will it work? I said, no. And then I gave him the same reasons. And then he gave me his next problem. He said, you don't understand. I have to change my entire staging area in my company because I have to build these servers, which means I need new electricity feed. I need new setup for the servers. So when I get the racks in together, I need to do all this before I can ship it to the customer. That's a real challenge that's out there. And we are actually bringing in, with the Power server, it's low electricity consumption. You all are using Power. You probably know of that. We're bringing in Spyre cards with low electricity consumption. And you could do the same that you are actually looking to run, with expensive GPUs as an example. So when you look at the Spyre stack, and this is kind of literally new, I'm sure some of my IBM colleagues are seeing it first time or maybe saw it before, but just giving you a view, as I said earlier on, in terms of the stack that you're looking at, right? You're going to look from hardware, your middleware, your operating system, your inferencing server, and then, with your applications and your service and support. So when you build a server today, you're going to have, your Power 11 server, you're going to have your I/O drawer because the Spyre adapter sits in an external I/O drawer. You have to build a configuration with 8 Spyre accelerators. And if you have running Power today, you would have Power VM, you would have your HMC. And then to get Spyre up and running, you would need your enablement stack for Power, which covers your driver, your backend, your runtime, your firmware, and the models that you're going to actually run. And then from a Spyre stack perspective for updates for Power, you'd have the same thing. When you look at the operating system, it has to be built with RHEL. So right now it's supporting 9.6. And then, the roadmap basically shows some of the other operating systems and our roadmap in terms of what's the next products that we'll bring on Power. Now, last week, we actually got OpenShift AI announced on Power. So that is as of last week. So you could see we're actually progressing a little further. And then when you look at what's the next components, last year when I met with a few clients and we were talking about AI, the first question I get asked is, does Watson Next run on Power? Watson Next or AI? The answer is no, right? Do we have a roadmap? Yes. And I think you can see the progress we made thus far. And we have Watson Next data, which is announcing next month. And with having OCP AI now also certified to run on Power, these are the building blocks of some of the Watson Next capabilities that we are bringing slowly, and eventually the stack will come clearer. And then when you look at it from a open source foundation, what are the catalogs and adoption patterns? And then if you're running your ISV and core applications, and then the support on top of that. When you buy the Spyre, IO drawer together with your server, and if you've already purchased your Power 11 server at the time of launch, you can add the Spyre adapter and its IO drawers, etc., as an MES. Or if you're buying the server, you can add it together and you'll get it installed by IBM. The software stack, and this is the differentiation between how we are launching this compared to the x86 vendors with GPUs, is the software stack that we're putting out here. You have to build this entire configuration with 3-year minimum for support, because you will get support on the software stack and the firmware stack to be able to run this. And I think you know why that's important, because the AI environment is changing on a daily basis. So how do we keep relevant to ensure that the customers have the latest, greatest in firmware and the software stack to be able to run it? So you will get regular updates with this. So it's a subscription for 3 years, and you get the software stack updated all the time. Kind of from a roadmap perspective, I touched about this a little, early on. You'd have from a digital assistant perspective, you saw that, Watson Code Assistant for I is now we had this in private preview. It was supposed to have launched in October. That's now, moved to Project Bob. And you've heard a lot of that yesterday from the IBM team that's here. From a data fabric perspective, we brought data stage and knowledge catalog in Q2 this year, and then launching, in 2 weeks' time or so would be Watson Next data, although it's in tech preview now. We've had a lot of customers do testing on this, so great feedback on that. And then from the foundation perspective, besides what we have from our ISVs, the work that our team is doing internally, we've had Red Hat OpenShift AI, on tech preview and now being announced. And as you can see, the roadmap actually takes into consideration from an AI infrastructure perspective all the items that we would actually look at. This is subject to change. We're seeing some things moving faster. We see some things being delayed for various reasons. But we will keep updating this, and you will get a view of this as you make inquiries. So how do you get started? Obviously, inform yourself. You understand our journey. You understand our strategy. And I mentioned this a little bit on Monday, is we offer a complimentary use case alignment workshop. It's important to understand what you actually want to do versus saying, I want to run an AI environment and I need to buy some infrastructure, and then you try to implement it and you have a challenge. With the use case alignment workshop, it brings together your entire organization, right? Obviously, the IT team is critical to that. You will bring in your line of business, HR, finance, etc., and they all have input in terms of what they actually want to use AI for, right? And then client engineering team from IBM will actually work with the business partner, work with the customer team to actually figure out which will be the easiest use case based on how your data is set up to implement with the lowest cost, obviously, because you don't want to spend a lot of money, with the quickest return. And then as you start, because that's a starting point, right? And then as you start, you might start with one use case, and then you have a roadmap, like we have a roadmap saying how we're going to build out from there on the infrastructure and capabilities we're bringing on Power. You would have the roadmap that says that, okay, you start with HR now, and then 6 months time you'll do finance, et cetera, et cetera. And that's the way you build it out. So that's an offer to you. If you want to partake of that, reach out to us, reach out to the local team here, and we can bring that capability to you. So with that, I thank you, and I'll hand over to my colleague Mark, who will take you through a live demo for a RAG solution. Thank you, Mark. Thank you.
Ok, merci. Bonjour à tous. Alors, ceux qui sont au fond là-bas, je pense qu'ils vont avoir quelques petits soucis de lecture, parce qu'après, on va dérouler 2-3 scripts, et c'est parfois écrit en petit. Enfin, je traduirai ce qui se passe. Donc, je me présente, je fais partie du Client Engineering à Montpellier, je suis solution architecte, et j'ai un background Power depuis pas mal d'années maintenant. Je connais certainement ça, pas mal d'entre vous dans cette pièce. Et donc, je vais vous faire une petite démo sur ce qu'on appelle la RAG. Donc, je vais vous donner la définition de la RAG. Et après, je vous ferai cette petite démo. Alors, c'est une démo qui se tourne sur P10. Ce n'est pas sur du P11. Je n'utilise pas les Spyre encore, puisqu'elles ne sont pas disponibles. Mais ça va vous permettre d'avoir une petite idée de ce qu'on fait et comment on le fait. Alors, juste pour introduire cette petite démonstration, alors, hop. Voilà. Alors ça, c'est un schéma qui illustre ce que c'est que la RAG. Alors, c'est un peu confus, mais je vais vous l'expliquer. Alors, en gros, pour un modèle, lorsque vous voulez qu'un modèle travaille sur vos propres données, dans une entreprise, par exemple, sur des process, sur tout un tas de choses qui sont internes à la société, à la compagnie elle-même, il y a 2 façons de procéder. Soit on fait ce qu'on appelle du fine-tuning, et le fine-tuning, c'est prendre un modèle qui a déjà été pré-entraîné, qu'on va trouver dans Hugging Face, par exemple, et puis, une fois qu'on a pris ce modèle-là, eh ben, on va l'entraîner sur des données à soi, des process, des informations qui sont représentées par des fichiers du style PDF, texte, etc., mais aussi des extraits de bases de données. Et donc, on va réentraîner ce modèle-là. Bon, ça, c'est une première façon de procéder. Alors, c'est bien, c'est assez rapide. En termes de temps de réponse, parce que le modèle a été entraîné sur les données. Par contre, c'est ça demande pas mal de temps, puisque dans ces cas-là, il va falloir réentraîner, dès qu'on a des modifications des procédures, le modèle lui-même. Alors pour ça, on va utiliser de l'OpenShift AI qui va être dispo au mois de décembre, par exemple. On va utiliser du WatsonX Data où on va stocker les données, etc. Donc ça, c'est la partie fine-tuning. Après, il y a une autre méthode qu'on peut utiliser pour faire ça. C'est ce qu'on appelle la RAG. Alors, cette fameuse RAG, vous voyez, c'est Retrieval Augmented Generation. C'est ça que ça veut dire. Comment ça marche? Eh bien, on a ici un utilisateur qui utilise un langage naturel et qui va poser une question à un modèle. Et ce modèle-là, il va être complémenté par des informations qui auront été mises dans une base vectorielle. Alors, voilà, ça c'est la première étape. On va prendre des informations dans des fichiers PDF, texte, encore une fois, des fichiers plats ou des fichiers qu'on va extraire d'une base de données, qu'on va mettre, qu'on va vectoriser. Voilà, on fait l'ingestion, ce qu'on appelle l'embedding. Dans la petite démo que je vais faire, on utilise ce qu'on appelle un sentence transformer pour faire ça. Donc on va les découper en morceaux et on va les mettre dans une base vectorielle. Une fois que l'utilisateur, lui, a posé cette question, on va faire ce qu'on appelle un similarity search. C'est-à-dire que dans ma base de données, là, je vais regarder qu'est-ce qui est le plus proche de ma question en termes de match, hein, de vecteurs. Ici, on va utiliser des vecteurs de 384 dimensions. Donc, vous voyez, vous avez fait des maths hein, en étant à l'école. Quand déjà on dépassait la dimension 3, on avait du mal. On se tordait un peu le cerveau pour comprendre. Ben là, on est bien au-delà et on a des bases vectorielles qui font beaucoup plus que ça. Et donc, la question, on va choisir à l'intérieur de la base vectorielle quelle est la donnée la plus proche de ça. Donc, l'extrait, c'est ce qu'on appelle le similarity search. Ça va être extrait de la base de données dans un format qui est ce qu'il est. Et derrière, on va le prendre et le renvoyer à un modèle, au modèle qui va mettre tout ça en forme pour donner une réponse qui soit lisible et acceptable de la part de l'utilisation. Donc en gros, c'est ça qu'on appelle la RAG, et c'est ce que je vais vous montrer. Alors avant de vous le montrer, juste un point. Ici, voilà le stack qu'on utilise. Et alors, on va utiliser un modèle, un Llama, ici, 3.1, 8 milliards de paramètres. On va faire ça sur un 10-22, 8 corps. Et après, alors, quand on tourne un modèle, on peut avoir différents runtime. Alors, sur les Spyre dont a parlé Ronnie, c'est un runtime VLLM, par exemple. Ici, je vais utiliser un runtime Llama CPP. Voilà. Donc, quand on s'adresse à des modèles, on ne s'adresse jamais au modèle directement, on s'adresse au runtime. Et c'est lui qui va être l'interface principale versus le modèle pour traiter toutes ces informations-là. Donc, on va utiliser aussi les instructions qui sont liées au processeur, donc tout ce qui est VSX, qui sont des... vous savez, sur le processeur Power, vous avez ce qu'on appelle des traitements, enfin des sets d'instructions vectorielles pour traiter des vecteurs, des matrices, etc. Bon. Et donc, on va utiliser ces sets-là pour faire en sorte que les performances soient le meilleur possible. Donc, le scénario de la démo, donc je vais me connecter directement à un modèle, vous allez voir, hein, c'est un chat, une interface qui ressemble pas mal à du chat GPT, et je vais lui poser les questions. Alors, pour installer le modèle sur Power, si on a déjà tout de près, ça prend allez, moins d'une demi-heure, enfin 15-20 minutes. Et après, je vais lui poser des questions sur les Spyre. Je vais lui demander qu'est-ce que tu peux me dire à propos des Spyre. Et là, il va certainement halluciner, il va me donner une réponse qui est complètement à côté de la plaque, parce que le modèle a été entraîné avant qu'IBM annonce les Spyre. Et ce modèle-là n'a pas accès à Internet, comme beaucoup de clients ne veulent pas qu'il y ait des accès Internet à ce niveau-là. Voilà, donc on reproduit fidèlement ce qu'on peut trouver chez des clients. Et puis derrière, ce que je vais faire, je vais poser la même question, mais en utilisant cette fameuse RAG, où on va vectoriser un readbook, qui est le readbook du 1180, dans lequel il y a une description des Spyre. Et du coup, vous allez voir qu'il répond plus facilement à la question. Donc on va faire toute cette étape-là, ingestion des données, du readbook. En fait, on va ingérer deux types de PDF. Hein. Le readbook et un autre PDF qui s'appelle IACT, mais là, je ne l'utiliserai pas. Et puis, je vais lui reposer ces mêmes questions. Vous allez voir la différence. Alors, je pose les questions en anglais. Je pourrais très bien les poser en français. Hein. Ça marcherait. Sauf que la traduction, le Redbook, il est écrit en anglais. Donc, le modèle traduit, mais parfois, la traduction, elle laisse un peu à désirer, et je trouve qu'on reconnaît mieux la réponse en anglais qu'en français. Donc, c'est pour ça que je vais poser les questions en anglais. Alors, je vais maintenant me connecter. Alors, je me suis pré-connecté, voilà. Donc ici, vous voyez, j'ai une adresse IP que je rentre dans mon browser. C'est l'adresse IP de mon runtime, Llama CPP, et qui me dit que j'utilise un Meta Llama 3.1, 8 milliards d'instructions. Voilà, c'est ce que je vous avais annoncé. Et alors donc, si je lui dis, par exemple, alors, tell me about Paris in... Ça marche, ça? Ouais. In 50 words. Voilà. Donc ça, c'est la réponse qu'il est en train de me donner. Vous voyez, on se rapproche de ChatGPT. Hein, c'est un modèle qui a été entraîné pour ça. Donc je suis sur un Power 10, ici. Vous voyez, les temps de réponse sont plutôt pas mal. Et maintenant, si je lui dis en AI, dis-moi ce que tu peux me dire à propos des cartes Spyre. About Spyre. Et là, il va certainement partir, soit il va me dire qu'il ne sait pas, soit il va partir dans des hallucinations. Voilà, il me dit, voilà, c'est un type de crédit card, il dit à peu près n'importe quoi. Donc il hallucine. Hein. C'est peut-être vrai, mais c'est pas... Ouais, enfin, je ne connais pas de carte Spyre en crédit card. Bon, je l'arrête, hein, parce que sinon il va continuer à me débiter des cochonneries. Alors ici, voilà, je suis connecté à ce qu'on appelle un Jupyter Notebook. Et là, on va exécuter différentes parties du Jupyter Notebook pour vous montrer un peu ce qu'il va faire derrière. Alors, là, je vous montre l'envers du décor, hein, pour que vous voyez bien les différentes étapes qu'on va tourner. Ça, on pourrait totalement le masquer, mais c'est juste pour, en termes d'éducation, que je vais vous montrer ça. Donc, je vais dedans. Là, ici, je supprime des collections qui pourraient exister. Voilà. Et là, je vais faire l'injection des PDF. Voilà, donc là, il se connecte à la database vectorielle Milvus. Il crée un schéma. Il crée une collection qui s'appelle RAG. Là, il me load les deux PDF. Il les vectorise et il les load dans la base de données. Et là, ça y est, il vient de le faire. Donc, vous voyez, c'est à peu près un Redbook de 200 pages, de 150 pages, je pense, et puis un AIAC. Donc, c'est assez rapidement. Il a transformé, il a vectorisé toutes ces données-là, qu'il a loadées dans la base vectorielle Milvus. Donc, alors, il découpe, enfin, je vais vous l'expliquer après. Donc, je vais jouer cette cellule-là. Et donc, là, il va me poser quelle question est-ce que je veux poser. Donc, je vais reposer exactement la même question. Et ça va aller au même modèle. Hein. C'est exactement le même modèle qui tourne au même endroit. On est sur la même partition. OK in AI. Je vais mettre la même. Regarding AI. Tell me about Spyre. Voilà. Alors, il va faire d'abord, vous voyez, ou pas, je ne sais pas si vous le voyez là-bas, je pense que c'est un peu petit. Il commence par faire ce qu'on appelle le similarity search. Ici. Voilà. Similarity search. Donc, il compare la question par rapport à toutes les données qu'il a à l'intérieur de la base et il va me sortir des vecteurs de la database. Vous voyez, le similarity search a duré à peu près 6 secondes. Et donc ça, c'est le résultat ici des différents vecteurs. Alors vous voyez, c'est pas super beau. Il y a des slash, il y a des choses, mais on commence à voir, vous voyez, on parle du 11, des machines 1180, on a tout un tas de choses. Et voilà, il va remettre ça dans une certaine forme, et on voit que on va passer ce qu'on appelle un contexte au modèle. Donc ce contexte est un peu plus joli que ce qui a été extrait de la database elle-même. Voilà. Et là, le modèle va reprendre tout ce contexte qui est quand même assez énorme. Alors vous avez des paramètres. Vous pouvez lui dire réponds-moi en 50 mots, réponds-moi en 200 mots, réponds-moi en beaucoup plus. Donc tout ça, c'est paramétrable. Hein. Évidemment, il faut connaître un petit peu ces paramètres-là, mais c'est pas très compliqué. Et donc voilà, il m'a donné la réponse ici. Et il me dit Spyre card are type of dedicated hardware accelerator designed by IBM for high intensive workload. Il met les caractéristiques, il me dit que ça fait 128 gigabytes de mémoire sur la DDR, sur de la DDR5, etc., 75 watts. Enfin, donc il me donne tout un tas de renseignements voilà, qui sont extraits de la base de données elle-même. Et donc du coup, on a des informations qu'on n'avait pas au préalable, puisque vous l'avez vu, il a complètement halluciné, hein, le modèle. Et alors que là, il me sort les vraies informations. Alors ça, c'est un exemple pour les Spyre, parce qu'on parlait de Spyre, et c'était le sujet de la présentation. Maintenant, vous voyez bien que ça peut très bien servir pour toutes les informations d'un client qui a des processus internes, qui a des informations, et qui veut fournir ces informations en langage naturel à partir d'utilisateurs qui posent des questions sur le sujet. Donc ça peut être très bien intégré à un IBMI, à du DB2, dont on va extraire un certain nombre d'informations. On y met aussi tout ce qui est relatif au texte non structuré. Alors pour ça, on peut utiliser aussi des outils Watson X Data. Je pense qu'il y a Andrew Braid qui fait partie de mon équipe qui va faire une présentation sur le sujet. Voilà, donc on peut mettre tout ça en avant et faire quelque chose de personnalisé pour les entreprises. Voilà, donc c'était une petite démonstration qui est assez rapide, mais qui montre qu'on peut tirer parti des informations en langage naturel qu'on va pouvoir downloader sur une base vectorielle. Vous avez des questions? Oui.
Moi, Marc, j'avais une question, c'est la disponibilité des bases vectorielles à l'heure actuelle sur Power. On en discutait avec certains dans l'auditoire aussi.
Oui.
Est-ce qu'on a une vue exhaustive des bases vectorielles qui peuvent tourner sur Power à l'heure actuelle?
Alors, pardon? Ah oui. Donc la question, c'est quelle est la disponibilité des bases vectorielles sur Power? Alors en gros, il faut regarder celles qui sont disponibles, mais celle préférée, c'est VectorDB, Milvus. Après, ChromaDB tourne aussi sur Power. C'est les deux principales. Il y en a quelques-unes autres qui tournent aussi. Toutes ne tournent pas, je l'avoue. Ouais, il y a des repositories. Il y a aussi, vous allez voir, je ne sais pas s'il va le présenter, notre ami Andrew, mais il y a aussi des logiciels open source qui vont être supportés là, dans les quelques jours qui arrivent pour chapeauter des bases de données qui ont des extensions vectorielles, par exemple Postgre. Et qui va permettre de faire tout ça. Ouais.
On en parlait, c'est pour ça.
Ah, ok. Voilà.
Merci.
D'autres questions? Oui.
Tu parlais de l'IBMI. Comment est-ce que ça s'intègre dans l'IBMI, ces cartes Spyre? Parce que là, je voyais dans ta présentation que c'était en termes de support OS sur du Red Hat. Est-ce qu'il y a des plans pour que ce soit vraiment intégré directement dans l'IBMI sans passer par des partitions tiers?
Alors pour l'instant, c'est comme ça que ça va marcher, en tout cas à la GA. À ma connaissance, il n'y a pas d'intégration vraiment directe, sauf si quelqu'un me dit le contraire dans la salle, mais il n'y a pas d'intégration vraiment directe. Je réfléchis. Non, de toute façon, ça va tourner sur du Red Hat Inference Server, hein, c'est ce que vous avez vu dans la vidéo tout à l'heure. Après, en gros, alors si, il y a quand même de l'intégration parce qu'il y a des API sur AX et IBMI qui vont permettre d'accéder au Spyre. Parce qu'en fait, la façon dont ça va marcher, c'est qu'il y a des containers qui vont être démarrés avec l'ensemble des drivers à l'intérieur et des connexions au Spyre. Et sur la partie AX et la partie IBMI, il y a des API qui devraient arriver directement.
Merci.
I have a question for Ronnie. You listed the options that we have to introduce Spyre to the customers, but there is something important that was missing, I think. What is the roadmap to actually get access to the hardware for testing and demonstrating? And what will be the options? Like a loan, like a tech zone, like IBM Cloud? Because it's going to be vital to the customers to really put their hands on the Spyre cards and load their data and run on their data and test for their actual use cases.
Thank you. That's a very good question. That's a good question that we often get, and in fact, Mark and I were having a long discussion around that this morning. So just for you to know, Spyre, the way it is set up today is for on-prem only. So on-premise, it's not going to be available in IBM Cloud. There is a demo unit that Mark and the team are busy with in Montpellier. So we have, I think, about 6 clients that are with the early adopter program that are doing testing for us. That's where it is. Once we go with general availability on December 10th, it will be available for customers and partners to buy. What we're seeing today is that some of the partners are looking to buy that so that they can then use it for demo purposes. And I'm not sure, each country has different regulations and requirements in terms of, let's say, IBM France having a demo unit, which they will then make available, to customers as well for testing. So those are the options that we're seeing that clients and partners are looking to leverage.
There used to be a loan pool of machines that was put in place, at least in Europe. I don't know about the US, but that would be a good thing to leverage this loan pool and this loan infrastructure if it's still up and running.
That'll be.
Don't you think? Because we used to loan machines in IBM France, and it's a lot of work for us pre-sales.
Yeah.
I mean, it's really tedious. And
no, yeah, you're right. Actually, we are working on it in Montpellier. I don't know what will be the results, but this is something we are working on.
In Montpellier, you're working on a remote access to some infrastructure sitting in Montpellier, or actually shipping some test
shipping.
Machines to the customers? Shipping? No shipping.
Yeah, no. Yeah. Being able to connect to the machine and do some tests. It's not available. I don't know if it will be available, but we are working on it.
Because a machine would only be a 4U setup of a small 2U power and the extension units for the cards. So
yep.
It wouldn't be a big deal.
I will take your query up to the global.
For sensitive customers with sensitive data, running in Montpellier will be.
Yeah.
We know.
We all know how difficult it is to get all the approvals, both at IBM and at the customer, when the data is sensitive.
No, that's valid. We appreciate it. Thank you for raising that.
Right. A little Je continue en français, pardon. Un peu de pub pour Montpellier. On organise, alors c'est un peu short notice comme on dit, mais le 3 et le 4 décembre, un petit tech exchange, une demi-journée de présentation, une demi-journée de lab. Dans les labs, il y aura du Power Virtual Server, il y aura de l'AI, en fait, qui correspond à ce que je vous ai montré comme RAG, mais les étudiants la mettront en œuvre. Et puis des labs sur Watsonix Data, comment jouer avec et voir qu'est-ce qu'il est possible de faire. Voilà. Donc pour ceux qui sont intéressés, le 3 et le 4 décembre à Montpellier. Question? Oui.
Alors j'avais juste une petite question. Nous on est sur IBMI. On a créé une partition Ubuntu sur le Power pour pouvoir mettre une base de données vectorielle. Alors on a pris Postgres pour l'instant avec DB Vector. Ça marche relativement bien. Par contre j'ai une question par rapport à l'extraction des données de DB2. Alors pour l'instant on s'est focalisé sur les données non structurées que demandent nos clients. Par contre, quelle méthode on peut utiliser pour extraire les données de DB2 et alimenter la base de données vectorielle?
Alors, c'est... pour l'instant, j'ai pas de réponse vraiment... comment je pourrais dire ça ad hoc. Mais une des façons de faire, c'est de faire des exports et puis... de la base de données et puis les rentrer dans la base vectorielle. Pour l'instant, c'est un peu ça la façon de procéder.
Donc des fichiers Excel ou des choses comme ça?
Ouais, des fichiers Excel ou alors avec des fichiers plats, des fichiers texte ou des choses comme ça, ouais.
D'accord. Bon, on s'est rendu compte qu'il va falloir lui expliquer ce qu'il y a dans les colonnes quand même pour qu'il puisse retrouver les différentes informations.
Pardon?
Il va falloir qu'on lui explique ce qui se trouve dans les différentes colonnes quand même. Si on est extrait depuis Excel, c'est pas si simple que ça. Parce qu'on l'a déjà fait aussi, donc. Non,
mais il faut travailler un peu, ouais.
Et après,
il faut lui injecter les données plutôt que les colonnes Excel. C'est pour ça. Je sais pas si Benoît a une idée sur le sujet, non? Non.
Il y a des moyens de le faire,
mais le seul moyen que nous on a trouvé. Ouais, c'est ça. Ouais. Parce que le seul moyen qu'on a trouvé, c'était de lui dire que le stock de l'article X de la désignation Y est de temps, et ça, il arrive à comprendre. Si on lui donne des fichiers Excel, c'est pas si évident que ça, en fait, pour comprendre. Après, j'ai une autre question.
Il faut travailler un peu la donnée avant de l'injecter, ouais.
Après, j'ai une autre question. Le provider llama.cpp, avec le Llama, il tourne sur le Power 10.
Oui.
Directement, d'accord.
Oui, okay, parce qu'il a été précompilé. Enfin, on en trouve des versions qui sont déjà compilées. Après, on peut compiler à partir des sources. Si on ne trouve pas la version que l'on veut, on peut le faire. Alors, c'est un peu fastidieux, mais ça marche.
Oui, mais ça, on s'est déjà cassé un peu les dents là-dessus. C'est vrai que... Mais il y a un repository qui existe pour récupérer en fait la version quelque part qui marche sur PPC 64 ?
Ouais. Je pourrais vous le donner. Ouais.
D'accord, ok, merci. Ouais. Et après, une dernière question, alors c'est autre chose. On a tous DB2 comme base de données. Quand est-ce qu'on aura une base de données vectorielle dans DB2 ? Comme ce que propose Postgres ? Est-ce que c'est dans les tuyaux ? Est-ce que...
Alors moi, j'ai pas la réponse. The question is, yeah.
No,
you know?
that's not in the roadmap, but it's something we need to take, right? So we just got Postgres, MariaDB, all those just announced and certified on Power. But that's a good point. We need to take that forward, to the development team.
Parce que ça nous éviterait en fait beaucoup d'interfaces.
Très clairement, c'est une très très bonne question. Ouais.
Voilà, merci.
Alors moi j'ai une question pour vous avant de donner le micro. Donc pour cet extrait de données que vous faites, l'objectif c'est quoi? C'est faire de la RAG comme j'ai montré ou Ouais, c'est ça. Ok. Et vous avez commencé à l'implémenter ou Ah, il ne marche plus.
Allô? Oui, c'est bon.
Ouais.
Oui, en fait, c'est pour nos clients en fait, qui ne veulent pas que leurs données sortent de chez eux. Hein. C'est un peu l'exemple que tu as donné. Donc, ils ont des données techniques où ils veulent faire des recherches, hein, ou même nous, nous on est éditeur de RP, hein, pour nos docs aussi, ça nous intéresserait d'avoir un RAG pour qu'ils puissent rechercher plus facilement.
Okay.
Et donc, on a déjà quelque chose qui tourne chez nous pour l'instant, et puis on espère le proposer à nos clients prochainement.
Okay.
Mais on est obligé d'utiliser une partition, de créer une nouvelle partition sur le Power pour pouvoir le faire là actuellement, pas le choix.
Tout à fait, ouais. Ouais. Alors, la RAG, c'est aussi un use case Spyre, et donc qui devrait masquer un peu toute la complexité. Alors, avec certaines restrictions, en termes de modèles, en termes de runtime, etc. Mais comme l'a montré Rooney, l'installation de la RAG, c'est clickable, donc en fonction des différents services que l'on veut. Et donc la RAG, c'est un des services qui va arriver avec le Spyre. Et le client Crest, dont a parlé Rooney, est en train de commencer à tester cette partie-là, justement, avec des Spyre. Voilà.
Oui,
juste pour info.
On est comme vous, on est encore sur Power 10. Et
voilà.
Si on veut proposer quelque chose de rapidement chez nos clients,
tout à fait.
On le fait dessus.
Bien sûr, c'est pour ça que moi j'ai montré ça, parce qu'il y a encore beaucoup de clients qui sont sur Power 10, pas encore énormément sur Power 11 et encore moins avec des Spyre, puisqu'elles ne sont pas GA. Mais donc je le dis pour information, quoi. Donc ça devrait simplifier beaucoup les choses. Voilà.
Oui, déjà avoir un modèle intégré, ça permettra de faire beaucoup plus de choses.
Ouais, tout à fait.
Merci.
So, Ronnie, you said that the AI vector features.
Just to be clear, because I browsed on internet in the meantime, and that's a question that follows up with the previous one. So you said that because there is an AI vector feature in the IBM DB2, but this is not in the DB2 for IBM I, right?
Yes.
Okay, but it's already in
the
DB2.
normal, yeah.
Okay, so there's still hope
Yes.
to get it on IBM I.
But like I said, the roadmap, we need to make sure we get it.
Okay.
Thank you. Power. Thank you.
And just to add something about the connector for between DB2 for I and the vector database, there is an IBM a Git website from Rochester that describes how to connect DB2 to the AI world, and there is a watsonx.data. So this is also something with connectors to DB2. So I guess that you can create a pipeline between your DB2 for I data source and a vector database. Maybe it's overkill for your use case. Maybe not. Maybe it's a good opportunity to come to the tech exchange to discuss that. Maybe.
Yeah.
Le QR code ne marche pas.
Ah. Okay. Right. Okay. I will talk to the guy who did it. Okay. Okay. Thank you for that. Other questions? D'autres questions, pardon. Je m'en mêle les pinceaux un peu là, entre l'anglais et le français. Ok. Ben, merci pour votre attention.
Thank you.